All right, guys, notes 26, super sick math problems. Um, yeah, it's pretty straightforward. This is geometry. The first three scenarios for a triangle. So we're talking about triangles, guys. We're going to derive the law of cosines in a little bit. There's only three types of triangles that you can get in Euclidean geometry. So in this whole universe, there's only three triangles. That's it. Now, if you include non-Euclidean geometry, there might be many, but just straight segments. We have this type of triangle. This is an acute triangle. Let's see, B, A, and C, where C squared is less than A squared plus B squared. Now, for a triangle to exist, the two smaller sides must be larger than the biggest side. Okay, that's fine, miss. The two smallest sides must be larger than the biggest side, guys. The triangles that you guys are most familiar with is a right triangle, BAC, where the C squared is equal to A squared plus B squared. That's just Pythagorean theorem. And this is just a right triangle, right? RIGHT. And then finally, BAC. And this is an obtuse triangle, where C squared is definitely greater than A squared plus B squared. Hopefully you guys remember that from geometry. Nothing crazy, pretty straightforward. Let's talk about how to label, guys. So I'm going to derive the law of cosines, but first let's talk about how to label these things. So vertices are known as endpoints, or the corners of your triangle. And you label a vertice with a capital letter. A, B, C. Those are capital letters. Angle A, so what is angle A? Angle A is this dude. Angle A creates little a. Angle B creates little b, and angle C creates little c. Nothing crazy, pretty straightforward. So if you want to figure out what side is created by what angle, or like a reference side, it's just the opposite side, guys. So there it is. So now that you know that, let's make a grid, and I'm going to exaggerate quadrant 1, and I'm going to write that same triangle, guys. Well, I tried to do the same triangle. A, B, C. If you look at first period's notes, I interchanged the letters. No big deal. You will still get the same answer. The A is located at the coordinate 0, 0. The B is located at a coordinate. We don't know that coordinate yet. The C is some x comma y, and I should put a subscript, but I'm not. I'm just going to say that's just some x comma y. So let's see. Angle A creates little a. So this segment between vertices C and B, or B and C, is segment A, or side A. And then angle B creates little b. And then angle C creates little c. Now, because I know that this side, and the horizontal side, that's C, the side C, because I know that is length of C, I can label this coordinate as C comma 0. Does that make sense to everyone? Perfect. All right, guys. So check this out. I'm going to draw a green triangle in there. So maybe if you have colored pencils, I don't know, maybe try them out. It's a little fun. It's a little fun to, draw. Do you guys see that green dashed triangle, guys? Do you guys agree that's a right triangle? I guess let me make it darker so everyone can see. All right, guys. So here we go. I'm going to go ahead and reference angle A here. And based off of angle A, I'm going to do some properties here. So if I want to use angle A, this horizontal displacement, this green that I'm bolding, that is just an x value because I have a coordinate here that says x. So that is just an x value. And then this vertical displacement that I'm bolding currently, that is just some y value. Does everyone agree with that? Perfect. So now I can say this, guys. I'm just doing SOHCAHTOA. No, don't, yeah, SOHCAHTOA, guys, just SOHCAHTOA. So sine of angle A is opposite over hypotenuse. So opposite is the Y value, hypotenuse is the B. And so that means if I multiply this, the left and the right by a B, you will have that B sine A. I guess I should write it as Y equals. Let me rewrite it. You will have Y equals B sine A. Same thing for cosine. If I write cosine of A, cosine is adjacent over hypotenuse, so x over b. Multiply both sides by b, and you will say that x is going to be equal to b cosine A. Does that make sense to everyone? All right. I think we're pretty good, guys. Now, let's focus on this triangle in blue. Chavez, why are you making all these triangles within your triangle? I don't know, triangleception. Which you guys might be too young. Maybe you never heard. There's a movie called Inception. It came out like 10 years ago, so maybe you guys have never heard of it. But so sometimes I'll have jokes like triangleception, and everyone will just look at me, and then I realize, oh yeah, I'm old. You guys probably haven't seen that movie. So yeah, so you don't know what I'm talking about when I say triangleception. But if you've seen the movie Inception, then you know what I'm talking about. Anyways, let's continue here. If I were to ask you, what is this distance? I want to know A. That's all I want to know. I want to know the distance of A. So the reason why I highlighted that blue triangle, we have two options. We can either use the distance formula to figure out the segment of A, or we can use Pythagorean theorem. By the way, the distance formula and Pythagorean theorem are brother and sister. They're related. They're the same. They really are. They're identical. They're not fraternal twins. What is the other? Wait, fraternal twins is when they're not the same? No, they're the same. Well, whatever. I'm going to edit that out because I probably sound like a dum-dum. So anyways, so there it is, guys. I'm going to use Pythagorean theorem to find out the distance of A. I'm going to put it on the outside. So all I'm doing is A squared plus B squared equals C squared. But I have all these different values that are not A, B, and C. So A squared on the outside equals, I want to figure out, and I guess I should color code it, A squared. I want to figure out the horizontal displacement down here, this guy. Well, I know that the segment from 0, 0, from A to B, I know that that distance is C. So I'm going to put parentheses, I'm going to write C. And I need to subtract the green part of the horizontal displacement. So I'm going to subtract X. Close it, put a square on it. Does everyone agree with that one right there? Plus, now I need my vertical displacement. Well, the top part, where vertice C is at, that's just a Y value. And then the X-axis, that's 0. So I can write Y minus 0, close it with a square on. So there it is, guys. There's my equation. And now I'm just going to substitute. I don't want to see this in terms of X and Y. I just want to see the letters A, B, and C. So I'm going to write A squared equals parentheses C minus what is X? B cosine A. Close it, put a square on it, plus what is Y? B sine A. Put a square on it. Now I'm just going to expand it, guys. I'm just going to expand it. A squared equals, I'm foiling. C times C is C squared. And then C times B cosine A, that's going to be BC cosine A, but I'm going to have two of those dudes. So minus 2 BC cosine A. And then negative B cosine A times negative B cosine A, that's going to be a positive B squared cosine squared A. And then when I square this dude, laws of exponents for the B sine A, that's just going to be B squared sine squared A. We're almost done, guys. I'm going to underline these two. I notice that I can factor out a B squared. So I have A squared equals C squared minus 2BC cosine A plus B squared factored out, cosine squared A plus sine squared A. And notice the Valentine's formula comes out. It's not a coincidence. I know that we are in February. Again, tell your significant other cosine squared plus sine squared equals 1, that your cosine squared, their sine squared, and together you guys are 1. And if they don't get it, just drop them. Go ahead and upgrade. Find yourself someone that knows that. And then from there, guys, since that's 1, I can just write it in alphabetical order, or at least some type of order logic here. So I'm going to write the B squared first. B squared plus C squared. And then I'm going to put this product here towards the end here, 2BC cosine A. and put that in a rectangle. And what you just did there, you just did law of cosines. Why do they call it law of cosines, Chavez? Well, I don't know. Probably because there's a cosine in there. So, yeah, I think that's why they call it law of cosines. So nothing fancy there, guys. So there it is, law of cosines. If they were to ask you, if someone asks you, well, can you do it in terms of B? Yeah, you can do it in terms of any letter, guys. So let's go ahead and rewrite it. If we were to ask, and we're not going to do all this again because I can see some of you guys, this was torture. If I wanted to do it in terms of B, I could just write B squared equals A squared plus C squared minus 2AC cosine B. What about in terms of C? Yeah, you can do it in terms of any letter. C squared equals A squared plus B squared minus 2AB cosine C. I want you to notice that if I have little a on the outside, it's angle A that I need. And when I say outside, I mean by itself, like to the left of the equal sign here. If I have B by itself on the outside, then it's angle B that I need. If I have angle C on the outside, which there really is no outside, so I should probably be using the different word. I have cosine C there. Does that make sense to everyone, guys? Awesome. All right. So now that you know that, here we go. It says, so let's see if we can let's see what we can do. Example 1, it says triangle PMF, measure angle. Really, I should have put angle there, guys. This is bad math on my part. I was typing fast. Angle M is 127 degrees, little p is 15.78, and little f is 8.54. Find the measure of the third side, little m. Okay, first thing I'm going to do, guys, I'm going to write NTS. It stands for not to scale. And then I'm just going to draw some triangle. That's point P, that's point M, that's point F. Point P creates little p, so this is 15.78 feet, that's little p. Point F creates little f, so this is 8.54 feet, this is little f. And point M creates little m, which we did not know. We know that angle M is 127 degrees. Perfect. We have everything we need. You have the two sides that meet up at M. And since we're looking for little m, I got everything, guys. So here we go. I'm going to set up. All I'm doing is using the law of cosines. So I'm going to use my law of cosines to find that missing side. I'm going to put that on the outside. M squared equals, and because I have angle M, everything's positioned perfectly. I like to write the smaller side first. If you want to go ahead and put 15.78 first, that's fine. 8.54 squared plus 15.78 squared. It almost looks like Pythagorean theorem, but we have this one added twist. Minus 2 times 8.54 times 15.78 cosine of 127 degrees. There it is. I don't want m squared. I just want m. So square root, that goes away. Square root of all that. Little m equals, I'm going to take out Desmos, and we're going to go ahead and type it in and see what we get. So here we go, guys. I need to get Desmos out. So let me do that. Share screen, Google. Yeah, and then Desmos. And I just need a little scientific calculator. There it is. Make sure you're in degree. You are. I'm just going to type it right in, guys. Square root 8.54 squared plus 15.78 squared minus 2 times 8.54. And I have to typing slow here, guys, because I'm using a mouse here. 15.78, close it, and then cosine of 127. And close it. And there it is, guys. They gave me 2 digits of accuracy, so 22.0022. So I'm just going to go back to this dude. Little m is 22. Put feet when applicable. Feet. when you're doing vectors, this is actually a really, really good law. This is a really good law to know, especially when you're finding displacements and stuff like that. All right, here we go on this one, guys. Question 2, it says, find the measure in triangle XYZ, little x is 3, little y is 7, little z is 9. Find the measure of the largest angle. Okay, again, I'm going to put NTS for not to scale. And I'm going to draw a triangle. It's definitely not to scale, guys. Capital X, capital Y, capital Z. Oh, it's 100% not to scale. This creates little x, that's 3. This creates little y, that is 7. This creates little z, that is 9. Angle Z creates little z. It is not to scale at all, not even remotely close. I know for a fact, I know 100% for a fact this is going to be an obtuse just by looking at it. How do you know that? Remember, guys, the two smallest sides here, 7 and 3. Well, 3 squared is 9. 7 squared is 49. And 9 squared is 81. The 9 is the biggest. And 81 is definitely larger than 49 plus 9. So because this is true, I know I have an obtuse triangle. And the way this triangle looks, I mean, well, angles, well, I don't want to give the answer away. There's a certain angle that needs to be obtuse, and it looks 100% acute on this. What is my largest angle? Angle X, angle Y, or angle Z? And how do you know? How do we know? Think about it, guys. Angle X created 3, angle Y created 7, and angle Z created 9. So which one's the largest angle?
Angle Z.
Heck yeah, Martinez, it's angle Z. Why? Give me a reason, miss.
Because it's across from the 9.
That's right. It's across. It's 9's the biggest. It's across from the 9. It has to be angle Z. Does that look obtuse? No, but it's not to scale. It's 100% obtuse, guys. So here we go. Let's go ahead and take care of this. Because we're looking for angle Z, it's the 9 that you're going to have outside on the law of cosines. So I'm going to write 9 squared equals 3 squared plus 7 squared. My habit is to put the smaller one first. You do not have to have my habits. If you want to put the bigger one first, go ahead. Minus 2 times 3 times 7 cosine of angle Z. Law of cosines is pretty easy to remember, guys. It's almost like Pythagorean theorem plus this added term that you're subtracting. So our job now, we're done. We're done with precal or geometry, if you want to call it that. All we're doing now, guys, is solving for cosine Z. So 9 squared is 81. 3 squared is 9. 4 squared is 49. Minus 2 times 3, that's 6. 6 times 7, what's that, 42? 42 cosine Z, sorry. And make sure not to do any algebra mistakes, guys. 49 plus 9, that's 58. Minus 42 cosine Z. Subtract the 58, so 81 minus 58. What's that? Minus 58, minus 58. 58, 68, 78, 79, 80, 81. That's 23. So 23 equals negative 42 cosine Z. And we're almost there, guys. Divide both sides by negative 42. I'm going to rewrite this right over there. So now I have cosine Z is equal to a negative 23 over 42. You don't have to put the negative in the front there, guys. I just had a professor who traumatized me, and he would always. Anyways, let's not talk about that. So there it is. You can, if you want to put the negative with the 42, that's fine. I'm going to find angle Z. So what I got to do is take the inverse of this. So Z is equal to, and really I should be putting an angle symbol, but that's fine. Arc cosine of negative 23 over 42. Notice I didn't write plus minus because I don't care about that, guys. You don't care about whatever the calculator spits out is your answer. You don't care about the negative part because it's in the context of this problem. In triangles, they don't have negative angles. So here we go. I'm gonna go back to Desmos. 23 over 42. I think I can remember that. And I'm just gonna type in arc cosine of negative 23 over 42. And there it is, guys. 123.2. 123.2. So let me go back. 123.2 degrees. And we're done. If you put the little angle symbol, that's fine. I should be doing good math there, but because it said cosine of z, I think everyone's pretty smart and everyone knows that z is an angle. We're talking about an angle here. All right, let's keep going. So look at example 3, guys. It says, suppose that the length of the sides in example 2 had been, okay, let me go ahead and change that. Had been x equals 3, y equals 7, and z equals 11. What would the measure of angle angle z be in this case? Okay. Don't worry, we're almost done, guys. I would hope and wish again that you can look at this and immediately know that this is not a triangle. It doesn't make a triangle, guys. For you to have a triangle, the two smallest sides must be larger than your largest side when you sum them up. 3 plus 7, 7, 8, 9, 10 is 10. And yeah, it's not larger than 11. So what you really have is something like this. Maybe even shorter. Yeah, something like that. 3, 7, 11. Nothing closes. It doesn't close. You don't have a triangle. If this were in a spindle, it would just fall down, or actually in a circular way. And nothing would hit. Like they would not connect. Nothing connects. So you don't have a triangle there, guys. So I would say not a triangle. And I wouldn't even bother trying to solve it with law of cosines. But if you did try, so let's see if we get an error message. Again, I'm finding angle z, so I'm going to put the 11 on the outside. 11 squared equals 3 squared plus 7 squared minus 2 times 3 times 7. Cosine of angle z. Excuse me. And I'm just going to go ahead and just start working it out, guys. 121 equals 9 plus 49. 2 times 3, so that's 42. So all this is going to look pretty much the same. 121 equals 58 minus 42 cosine z. Subtract the 58, subtract the 58. 60 and 60 is 120, and I am 3 away from 58 and 21. Okay, so that's 63. So negative 42 cosine z. And then I'm going to divide by negative 42. And look what happens. Cosine z equals a negative 63 over 42. Angle z is arc cosine of negative 63 over 42. If you type this on the calculator, you will get an error if you're using a TI product or undefined. Or if you're using a TI-84, you'll get error. Why? Why is it undefined? Why do I get an undefined there, guys? I mean, I know I don't have a triangle, so I know you can say, well, you don't have a triangle, but tell me why our cosine is undefined for this ratio. Do we have anyone that knows why, guys? Oh, man.
Is it because it wasn't true since the beginning?
Well, it wasn't true since the beginning. That's true.
Because it's larger, like the numerator is larger.
Okay, yeah, the numerator is larger than the denominator, which means that this is a magnitude larger than 1. So the ratio on the inside, guys, the ratio must be between -1 and 1. It can't even be this number. It can't be a -1 or a 1 because then you don't have a triangle either. But it must be between that. In the unit circle, guys, cosine, the biggest it is 1, and the smallest it is -1. So you can't take inverse of cosine if the biggest and smallest is 1 and -1. Does that make sense, guys? I just saw someone walking the hallway and all they saw me is, I'm just doing this stuff. So I wonder if they think like, what is this guy doing? Is he a bird? Okay, anyways. So yeah, guys, that ratio must be between -1 and 1. All right. So let's continue. We're almost done. We should be done in like 5 minutes here. Maybe even less. Example 4, this is coming from your Delta Math activity today. So a lot of people yesterday were able to get the Delta Math done like in 10 minutes. And then some took 30, and then some decided to wait until the evening. That's fine. So it's your choice. But today's Delta Math is going to be pretty simple, guys, I think. So here it is. Triangle TUV. V is 20, T is 11, and angle U is 47. Find the length of U to the nearest centimeter. All right. You don't have to draw a sketch, but I think for you visual learners, I think it's important. So I would do a little sketch, not to scale. Here's capital T, here's capital U, here's capital V. So capital T creates little t, and I have a length for little t, that's 11. So I'll put 11 centimeters there. And then capital V creates little v, so this is little v, so I put 20 centimeters there. And then angle U is 47 degrees. Perfect. This is little u up here. I have everything I need to use the law of cosines to figure out a number. So u squared is equal to, and I like to write the smaller number first, 11 squared plus 20 squared. If you want to use parentheses, go ahead. Minus 2 times 11 times 20 cosine of 47 degrees. I want to get the square out, so square root, that gets that out, square root. So u equals, and you just type this in a calculator, and I guess I'll take out the Desmos here real quick. So Desmos, and I'm just going to go square root, and I'm just going to type it in. 11 squared plus 20 squared minus 2 times 11 times 20 cosine of 47. So there it is, guys. 14.86. They did say near a centimeter. 14.863. So remember that, 863. 14.863 centimeters. So that means U is 15 centimeters. All right, last problem, guys. Oh, sorry. I saw some of you guys still writing. Last problem. Let's see, question 5. So it says JKL, triangle JKL, J is 9.6, K is 6.4, and L is 8.4. Okay, so they give me all 3 sides. Find the measure of angle K to the nearest degree. So not to scale again. And triangle JKL, all capital letters. So angle J, or little j, is 9.6. So I put a 9.6 right there, inches. Angle L, or I guess let's do K. K is 6.4 inches, so that's 6.4. And L is 8.4. And they want me to figure out angle K. So if I'm going to figure out angle K, I'm going to have the 6.4 on the outside, quote unquote, on the left-hand side of my equal sign. 6.4 squared equals 8.4 squared plus 9.6 squared minus 2 times 8.4 times 9.6 cosine of K. So let's see what these are, guys. Someone do me a favor and tell me what 6.4 squared is. And then someone do me a favor and grab these two numbers, 8.4 squared plus 9.6 squared, and tell me what that is. And I'll take care of this one over here. 2 times 8.4 times 9.6. 2 times 8.4 times 9.6. 161.28. Got it. Minus 161.28 cosine K. All right. What was 6.4 squared, guys? I think I saw it on the chat screen, but it disappeared. Can you unmute yourself and just say it real quick, please?
40.
Oh, you got it.
Sorry.
96. Okay. And then what was these two? The 8.4 squared plus 9.6 squared? Should be pretty close to the 160.
It was 162.72.
Perfect. Yeah, that sounds correct to me. There it is. And now what I'm trying to do is get K by itself. So I'm going to subtract the 162.72 minus 162.72. So go ahead and take the 40.96 and subtract 162. It should be like 120, but negative 160, 50, 40, like 120, 121 and something, or 120 and something. 121 and something, it looks like. Negative 121 point something.
0.76.
0.76 equals negative 161.28 cosine K. We're so close. I'm going to get cosine K by itself by just dividing by negative 161.28 there. Negative divided by negative is a positive. So I have cosine K equals 121.76 divided by 161.28. And then finally, for my last step, K is equal to arc cosine of 121.76 divided by 161.28. I think I can remember that. Let me know if I make a mistake when I'm typing this in. Come back here. And let's see, it was, I'll push enter there. It was arc cosine of 121.76 divided by, I think it was 161.28. I think I got those correct. Let me know if I didn't, because my memory sometimes, short-term memory is bad if I don't sleep enough. 40.978, let's go back. 40.978, it's a degree, and I think they said to the nearest degree. They did. So K is 41 degrees. Give you guys a little bit. All right, guys, I'm coming back.